This video is going to go over the Module 11, Are You Ready? So the skills that we want to work on today are identifying quadrilaterals and using a coordinate grid to graph or locate ordered pairs. So we are going to be graphing quadrilaterals onto coordinate graphs in Module 11. So we want to make sure we understand what different polygons and quadrilaterals are and how to use that graph. So first we have a polygon that we need to understand. So a polygon is any flat 2D shape. It has to have straight sides and it has to be fully closed in. So we are going to go through and we are going to identify any of these polygons. So they're flat shapes, they need straight sides, and they have to be completely closed in. So let's try here. So if I click and it doesn't fill in, that means it's not a polygon. So what is making this shape not a polygon? Well, it's not straight. It is fully closed, but it does not have straight sides. Here we have a polygon, straight sides, closed in. This one has this arch here, so it's not straight. Straight sides, closed in. So this, right, is a rectangle. This one's a triangle. Both of these are also polygons. They have better names, rectangles, triangles, but they are polygons. So polygon, straight and closed, and straight and closed. This is a polygon. And notice this one is not closed in, so it is not a polygon. So now we're going to take that information and discuss quadrilaterals. So quadrilaterals are a polygon, so that means it has to be a polygon, straight sides, closed in, and they have exactly 4 sides. So let's look here. So notice this one has 1, 2, 3, 4 sides. They're straight, but it's not closed in. So that is not a quadrilateral. Straight, 4 sides, exactly closed in. This one is straight and closed in, but it only has 3 sides. This would be a triangle. This word quad means 4. So 1, 2, 3, 4, closed in and straight is a quadrilateral. This one has 5 sides, so it is closed in and straight, but it has 5 sides. 1, 2, 3, 4 sides, closed in. 1, 2, 3, 4 sides, closed in. This one only has 3 sides, and this one does 1, 2, 3, 4 sides and closed in. So all of these shapes that are highlighted, they are quadrilaterals. They have 4 sides, they're straight, they're closed in. So we're going to look at these 5 shapes here. These have better names. So yes, these are all quadrilaterals, but we can call them something better. So next we have a parallelogram. So a parallelogram has to be a quadrilateral. So that means it's a polygon, straight sides, closed in, 4 sides exactly. And this time it has 2 sets of opposite parallel sides. So that word parallel means that you have 2 lines that if they were extended will never ever touch. So even if these 2 lines go on forever, they are straight across from each other and will never touch. We can also turn them on their sides, so they don't just have to go up and down. They can go across from each other. So opposite just means they're across from each other, and if they're extended, they will never, ever touch. So let's fill in our parallelogram. So we're looking for 4 sides, and the opposite sides, both of them, have to be parallelograms, or parallel. So here we can see this side is parallel to the top and the left is parallel to the right. So 4 sides, top and bottom are parallel, sides are parallel. So let's come down here. So same thing. So you might recognize this as a square, but the sides will never touch if they keep going and the top and bottom will never touch. Let's come down here. So this one is not a parallelogram. The top and the bottom are parallel, but if we look at these sides here, if we keep extending these sides, we can see they're going to crisscross and touch each other eventually. So this is not a parallelogram. Our next one, let's come up here. So this is really just a square turned on its side. So this side and this side are parallel, and this side and this side are parallel. So we can check that by drawing those lines here and this one here. I kind of missed that one. But these are never going to touch, and then we can do the same thing here. This line is never going to touch this line, so they're just going to keep going straight with each other. Here, so I can see, right, the top and the bottom, these sides are parallel, these sides are parallel, but a parallelogram has to have 4 sides to be a quadrilateral. So even though, yes, these are all parallel, the opposites are parallel, this has 3 sets of opposite side, parallel sides. We just want 2 sets. Okay, and our last one here is this parallelogram, the left and the right. So even though they're slanted, they go at the same angle, and the top and the bottom are also parallel. So here is 4 examples of a parallelogram. Okay, next we're going to look at rectangles. So this is one I imagine you are pretty familiar with. So a rectangle is a parallelogram. So that means it has 4 sides and that the opposites are parallel, but it also has 4 right angles. Okay, 4 right angles, and then the 2 sets of equal opposite sides. So the opposite sides are the same, and it has to have 4 right angles. So let's take a look here. So if I do this one here, yes, so I can see, right, it has 4 right angles. It's just tipped on its side. They're parallel. This side is the same as this one. This is the same as this one. So let's come here. This one is not a rectangle. If I look in the corners here, so even though the sides are parallel and equal, the angles are not quite 90 degrees, so this is not a rectangle. So here's a true rectangle. So the top and the bottom are the same and parallel. The left and the right are equal and parallel, and all of the corners are right angles. So this is a rectangle here. So yes, this is a parallelogram, but a better name for it is a rectangle. So this one is not a rectangle because it does not have 4 sides. It has 6, and they're not right angles. So here's another example of a rectangle. Top and bottom are equal and parallel. Sides are equal and parallel, and 4 right angles. Down here, we have another example of a rectangle. Top and bottom are equal and parallel. Sides are equal and parallel, and it has 4 right angles. You might know this as a different shape, which we'll talk about in a minute, but it is also a rectangle. It's also a parallelogram. It's also a quadrilateral. Those aren't their best names, but it is a rectangle because it fits all of the characteristics of a rectangle. So down here, we can see, right, this does not have right angles, and the opposite sides are not parallel. And here, this is a parallelogram, so they're parallel on opposite sides, and they're even equal, but they don't have 4 right angles. These are all slanted, so this is not a rectangle. This is a parallelogram. Next, we are going to look at a rhombus. A rhombus is a parallelogram, so the opposite sides are parallel, and all 4 sides are the same. So on a parallelogram, only 2 sides, the top and the bottom, or the side and the sides are equal to each other. But on this one, we have to have all 4 equal. So let's take a look here. So this one is a rhombus. So I can see the top and the bottom kind of here, and these 2 sides are parallel, And this side, this side, this side, and this side are all the same length. So this one is not a rhombus. So it does have opposite sides parallel, but all of the sides are not equal, so it's not a rhombus. So this one is not a rhombus because the four sides are not equal to each other. So here we have a rhombus, parallel sides on the opposites, but all 1, 2, 3, 4 sides are the exact same length. So this is a rhombus here. So this is not a rhombus because all four sides are not equal. So here we have another rhombus. Opposite sides are parallel, and it has all four sides of equal length. This is not a rhombus because the four sides are not equal, and it's not a parallelogram because we've learned that these two sides would crisscross and intersect each other. And this one is not. So this is a parallelogram. It has opposite parallel sides, but the four sides are not equal. So this is just a parallelogram, not a rhombus. So a rhombus is more similar to a square. It has to have the four equal sides. So it can be a square, but it doesn't have to have the right angles. The four sides just have to be exactly the same. Our next one we're going to look at is a square. So it's a parallelogram. So that means the opposite sides are parallel, and it has four equal sides, and it has four right angles. So this part here is similar to the rhombus. It has four equal sides. And then this part here is similar to the rectangle in that it has four right angles. So a square is really a combination of a rhombus and a rectangle put together. So let's identify any of our squares here. So right angles and four equal sides. So this is a square. It's just turned on its side. I can see right angles. I can draw those squares in the corner. This is not a square because the four sides are not equal. Not a square. They're not equal. So these four sides are equal, but it doesn't have four right angles. So not a square. Not a square because it doesn't have four equal sides. Not a square, doesn't have four equal sides or four right angles. Not a square, the sides aren't equal, the angles aren't right. So here is a square, four right angles, four equal sides. So this square, we can see as we go back through, the square was a rhombus. It has four equal sides. This square is a rectangle. It has four right angles. This square is a parallelogram. The opposite sides are parallel. This square is a quadrilateral. It has four sides. This square, we can actually put on this polygon page too. Oh, that's not a square. This square is a polygon. It has straight, closed-in sides. So a square can go by a lot of different names, but its best name is a square. So it's kind of like saying, right, it can go by all these different names. It's like I have a lot of nicknames. It's kind of nicknames for it, but its real name is a square. Okay, our last shape we're going to look at is a trapezoid. So a trapezoid is a quadrilateral, so four sides closed in and straight, but this time it only has one set of parallel sides. So exactly one set of parallel sides. So let's try some of these out here. So I can see, right, we know this is a square. This has two sets of parallel sides. We just want one. This one here, I can see the top and the bottom are parallel, but the sides are going to crisscross. So it has one set of parallel sides. So this is a trapezoid. This is a parallelogram because it has two sets of parallel sides. We just want one. Here's a trapezoid. It's just turned on its side. So I can see the left and the right this time are parallel, and we'll just go up and down where the sides, the top and the bottom, are going to crisscross. So this is a trapezoid. Here's a trapezoid. The top and the bottom are parallel. The sides are not. This is a rectangle. It has two sets of parallel sides. Here's another trapezoid. The top and the bottom are parallel. These sides here are going to crisscross. And here is a trapezoid. The top and the bottom are parallel, and the sides will crisscross. So there's lots of different things that a trapezoid can look like. You just need to know it has one set of parallel sides. So let's look at these shapes here, and we are going to drag the shape to any words that describe it. So let's start with quadrilaterals. So what do we know about quadrilaterals? Four sides, closed in, straight. Four sides, closed in, straight. So this is a quadrilateral. Four sides, closed in. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So all of these shapes are quadrilaterals. That doesn't mean it's their best name, but they are quadrilaterals. So now let's look at our parallelograms. So parallelograms have two opposite parallel sides. So here's top and bottom, left and right. So this is a parallelogram. We've got the top and the bottom, but left and right are going to crisscross, not a parallelogram. Parallel, parallel, there's two. Parallel, parallel, there's another one. Parallel, parallel, there's another parallelogram. So notice this one here is not a parallelogram. So let's move on to our rectangle. So we're looking for two, so it has to be one of these, right? The two sides are parallel. But this time we need to straighten it up, and we can only choose the ones with right angles. So here we can see, right, these are parallel and four right angles. So this one is a rectangle. Parallel, four right angles. The green one is a rectangle. The blue one does not have right angles, and the orange one does not have right angles. So out of these shapes, the yellow and the green are the only rectangles. So let's move on to our rhombus here. So we know our rhombus has to be a parallelogram, and it has to have four equal sides. So these are all parallel. We've already decided that, but the yellow does not have equal sides. Green has equal sides, so we can move green up into the rhombus. Blue has equal sides. Orange does not have equal sides. So these two are examples of rhombi or a rhombus. And let's look for a square. So we know a square has to be a parallelogram. It has to have four right angles, and all of the sides have to be equal. So this does not have equal sides. The yellow one doesn't. The blue one does not have four right angles. The orange one doesn't have equal sides or right angles, but this green one has four equal sides and four right angles. So you can see this green one is the only one that is a true square. So yes, we've got multiple rhombi here. We've got multiple rectangles, lots of parallelograms. They're all quadrilaterals, but then they have a best name for them. So then our only one that was a trapezoid that had one set of parallel sides was our pink one here. So this page here told us any of their nicknames. Now let's do their best name. So let's start here with this yellow one. So what is if you could only put it in one of these categories, which one would you put it in? So this one is a rectangle because it has parallel sides and four right angles. So this yellow one, the best name is a rectangle. The most specific name for it is a rectangle. So let's come to our pink one here. So four sides, the top and the bottom are parallel, but the sides are not. It only has one set of parallel sides. That is a trapezoid. Let's come to our green one here. So we know it's parallel on both opposite sides. It has four right angles and it has four equal sides. So it's very specific. This one is a square. Everything about it is the same. All the angles are the same and 90 degrees. The sides are the same. The sides are parallel to each other. Okay, let's come to our blue one. So here we have 4 equal sides. Opposites are parallel, but it does not have right angles, so it's not a square. It's a rhombus. So this one here has opposite sides parallel, and it does not have equal sides, and it does not have 4 right angles. So the best name for this one is a parallelogram. So notice, yeah, these were all quadrilaterals when we come back here, but that's not their best name. They each just have one specific best name, but they can be known as other things. Okay, so let's move on to our graphing here. So remember, we always want to use the x-axis first and go over, then up. So let me get a pen. So A is over 7, up 3. So we put them in parentheses, 7, comma 3. We always want x first, then y. It's like our elevator. We have to walk over to the elevator. So I walked over 8 steps, and then I went up to the 10th floor. So over 8, up 10. So go ahead and see if you can find where is C. So this time I'm already at the elevator. I went over 0, I'm already there, but up to the 8th floor. And go ahead and see if you can locate D. So we had to walk over 4 units, and then we went up 6, 4, comma 6. So when we're writing these, we show parentheses, we separate them with a comma. That lets us know this is an ordered pair on a coordinate grid. Okay, our last ones this time. So we always start at 0, 0, the origin, over 5, up 4. And we notice I don't put a dot and a dot. I'm just tracking. I put a dot at the final location. So B, we want to start at 0, 0, go over 3, and up 10. Here's B. And then C, we're going over 7, up 1. So notice, right? We just put 1 dot for each of them. I didn't dot, dot. Just track. Place your dot at the final location. So go ahead and do your Are You Ready? And also complete your Module 11 opener for today.